All right, so have a nice day, everyone. So thank you so much for following this video. So class, we'll continue with the next video, which is all about still the graph. And in this video, we'll also focus directly for the insertion of the edge in terms of the adjacency matrix. So that will be our focus in this video then. So for the adjacency of matrices, the operations that we will follow first, we'll discuss first how does it work. So the adjacency matrix to add edges between two existing vertices such as x and y, then the elements of the graph of x and y or I or j and G, Y, and X of the adjacency matrix, that's matrix, will be assigned to 1. So if that is adjacent as right now, that will be assigned to 1, diba? That is actually how does it work. But since I know that in your adjacency matrix, that kind of vertex, for example, C and D as right now, this is your X and this is your Y or I or J. If that certain edge is not yet there, or they are the X and Y is not adjacent yet, that is 0 in your adjacency matrix. And if you don't know how to do with the adjacency matrix, so you can actually refer to the first video that I was able to discuss all about the adjacency matrix then. So let's actually move on in terms of the edge insertion for undirected graph and using the adjacency matrix. So first then, you need to go ahead and deal with the adjacency matrix of this particular graph. So suppose in your adjacency matrix, you have to declare all of the vertices that you do have, right? So if you can remember, that will be, you will compare each of your vertices to the I and J. So since I was able to explain that, how to do it in the last video, so I will not be going to do it here. Just refer to the last video that I've created. Now, this will be the result of your edge insert of your matrix in pertaining to that one. So since your goal is to add path from B to C and C to, or C to B, since regarding with insertion in terms of undirected graph, as what I've always mentioned, that they can be read as vice versa. So you can read that B, C, or C to B, vice versa. That is all right, or that won't matter here then. So since B or C, so you will be going to go ahead and check that in here. B to C, that is, no, that is A to C. I'm so sorry. B, this is B, and this is C. So that is 0 as right now. As well as your C and B. C and B is 0. Since in your adjacency matrix, they are symmetric to each other. And as I was able to discuss that then in the previous video, what is symmetric. So of course, you can definitely add the BC and CB right now, since we are talking to an undirected graph right now. So since this is 0 here, so once you will add the certain edge in that particular graph, so you will also update the 0 into 1, since the rule of adjacency matrix, if you the certain I and J and vertex, if they are adjacent to each other, you will update that into 1. So this will be the added link already for the B and C, and this is how we update the matrix as right now. So that is really simple. So if you know how to get the adjacency matrix, so you need to actually go ahead and step by step that one. And of course, you have to draw another graph, and you also have to perform, or you need to do another adjacency matrix for the update of that. So that is actually how does it work for undirected graph. So let's actually now proceed with the edge insertion in terms of directed graph using still the same for the adjacency matrix. So suppose that we do have here the graph for the adjacency matrix. You will still do the same thing, and our goal is to insert the directed path of B to C. So that is B to C. That means to say your from B, that will be outgoing arrow down to C, and that is from if you are in the vertex C, that is ingoing arrow from vertex B. So that is your goal that you need to add in this certain situation. So let's actually go ahead and figure out the adjacency matrix. This will be the adjacency matrix in this particular graph, the same thing. And in your adjacency matrix in terms of the directed path, remember that is not symmetric. So if you want to know about that, you can refer to the previous video that I've created as well. So suppose that you was able to add already the path for that one. So we add that here successfully then. And we will just also update in terms of our adjacency matrix only for the B to C, not C to B, since that is regarding to their that is regarding to the goal that you want to achieve, then it's only B to C, and that won't be read as vice versa C to B. So here then you only update the B to C matrix, so that's actually so simple. So if you want to understand with regards to the adjacency matrix how to get that one, you can refer to the previous video that I've created. So thank you so much for listening in this video right now. So that's the end of our presentation, and we will be in the next video. I will also make sure to discuss in terms of adding the vertices in terms of adjacency list as well. So before I will go dive with the deletion afterwards, I will certainly, what if you will add a certain vertex in your adjacency list, both for directed and undirected graph as well. And thank you so much. Bye-bye for now.